Hello and welcome to the continuation of the lesson of 12.3 surface area of pyramids and cones. We did most of these notes in class, you'll recall, but we didn't get to talk about cones. And so what I'm going to do is I'm going to let you have a chance to maybe copy some things down, especially if you were gone and watching this video. You can still get all the notes filled out if you will pause the video to copy things down as you see them. Once you have them paused, go ahead and click play. And so if you haven't yet, pause the video to copy this information down. Go ahead. All right, and now we should be ready to take a look at this first example. So here are our first two examples, and you can kind of see what I've done here. I'm just using this formula, plugging in perimeter, slant height, and getting my lateral area for both of these examples. So copy those down. Pause the video so you have enough time to do that. All right. Now remember, slant height is the height of the slanted triangular side of a pyramid. If you are not given the slant height and given the actual height of the pyramid, you can use Pythagorean theorem to find the slant height. Okay, but then to do surface area, we just add one base area to that lateral area because there's only one base of a pyramid. Okay, and so this led us to these examples, and so you can kind of look at what we've done here. I'm just using the surface area formula. This is lateral area plus base area. And these are the examples where I did not give the slant height, but we used Pythagorean theorem to find the slant height. So you can copy these examples down if you were gone by pushing pause now. All right, so you should have these and have these correct answers. And then we did example 3, which is when the base of our pyramid is not a square, but in this case, a hexagon or any other regular polygon. We have to use our apothem. Okay, remember that capital A there stands for the apothem. Okay, and we use that to help find that base area when we add in our base area. All right, and that leads us to being able to talk about lateral area and surface area of a cone. And it works out very much the same way that lateral area and surface area of pyramids worked out. Okay, the lateral area of a pyramid was 1/2 perimeter times slant height. Well, the perimeter of a circle is actually the circumference, and remember that circumference equals 2 pi r. So half of circumference equals just pi r, if I divide by 2 on both sides. So our lateral area formula, you'll notice, is just pi r times the slant height. Okay, pi r is just your half of your circumference. Where r is the radius, L is still the slant height. It's still the length of that, or that height measurement on the slanted curved side of the cone. And then to do our surface area, we're just going to take lateral area plus an area of the circle. There's only one circle, so we just add in pi r squared once. So surface area is that full formula. So here's the two areas we're going to use in example 4. And this shouldn't take us too much time at all. In fact, I will do one for you, and I will let you pause the video to complete the second one because they're very much the same. Now, here's what we have. We have that the radius of your cone is 1.4, and when they write the 3.2 along this side, they're referring to the slant height. So that is your slant height. So both of these examples, you're given the slant height. If you were given this measurement, we would need to use the radius and that measurement and in our Pythagorean theorem to find that hypotenuse, which is the slant height. But it's a lot easier this time. So we're going to find the surface area, not just lateral area separately. We're going to find surface area. So I'm going to use that full formula, pi times radius times slant height plus pi times radius squared. Base area, lateral area. Okay, so I'm just going to plug in what I know. The radius is 1.4, slant height is 3.2, and back to our radius of 1.4 squared here. And so I'm just going to do whatever calculations I can on and write those results on paper and multiply by pi at the very end, hopefully. 1.4 times 3.2 is 4.48, and then we have that times pi, plus our 1.4 squared, pi would be 1.96 pi. So I'm going to add 1.96 and 4.48 to combine like terms. and get 6.44 pi, and then we're going to go ahead and multiply by pi to round our answer to the nearest tenth. So that's approximately 20.2 square centimeters for our surface area. And if it had asked for lateral area, it would have just been this 4.48 pi, so I would have done that calculation in the calculator and rounded that answer as well. Alright, I'm going to let you try and do part B on your own, and then when you are ready, unpause the video. That means you'll need to pause it first, obviously. But when you're ready, click play and you should see what we get. Alright, this is what we should get for our surface area of this cone. Remember the formula. Surface area equals pi r times slant height L plus pi r squared. The radius is 3, the slant height is 4.5, so we should get this. When we multiply all these together and combine like terms, it's about, or exactly 22.5 pi, which is approximately 70.7 square centimeters. Alright, that sums up how to find surface area of cones. You just make sure you're using the correct formula and you should be just fine. Make sure that you use these notes in completing the worksheets. I have attached the 12.2 and 12.3 answer keys to the Edmodo post so that you can grade those assignments. And 12.2 and 12.3 worksheets are due Monday when you get back after the long weekend. So hopefully you have a good weekend and you understand how to use these formulas.